Good morning. It's Monday, March 22nd, and we are starting our first video of our, I guess we're calling it independent study. Hopefully you guys are all on board and you have your packets. Either you picked one up from Clovis West today, or maybe you just are downloading it and printing it off the internet from my website, bradzimmer.org. Every morning I will post a video. It will usually consist of some notes for the lesson of the day and some solutions for the previous day's lesson. I will typically do the odds and let you guys do the evens. Hopefully you're doing them all on your own, and the solutions I'm doing are just to show that you are doing them correctly or to point out that you've made some mistakes and you need to redo some problems. I won't do the evens. We're going to see if you can get those done on your own. Today, I'm going to start off by just doing part of the Math 1 review worksheet. That is your assignment for the day. I'm going to do number 1 with you guys because that is a lot of what's going on in the beginning of this chapter or this unit. So let's jump right in. Name 2 lines in the figure. So we're looking at this figure over here, and there's basically 3 lines here. We have this line right here that is on the plane. And we have this line right here that is also on the plane. And then we have this line RN that is basically piercing through the plane. In fact, this part back here that you can barely see is dotted to show that it is actually behind this plane, and you really wouldn't be able to see it if it was a solid plane. So name 2 lines. So we could say line AX. And remember, when we write the name of a line, it has to have the little line above it with the arrow on each side. We could also name that line XA. Remember, because a line doesn't have a direction, we could name it with any of the 2 letters that are actually on the line with a line above it. We could also say line MC or line CM or line MN or NM. So I'll put one of those down. I'll say line CM. And of course, this line right here that is actually coming out of the paper, if you could think of it that way, it's 3-dimensional. We could call this line RN. So this is 2 different ways to name this line that is basically running horizontal on the page. This is one way of naming the line CM that is running basically vertical. And we have line RN that is basically piercing through the plane. Name 4 points that are not collinear, or we would say non-collinear, meaning not on the same line. So really, we can pick just any points here. We can pick point A, and we'll just say A. And we could pick R because it's not even on the plane. And let's pick M over here. And let's go with X. So those 4 points are non-collinear. Okay, now any 2 of those points could be on the same line because all it takes is 2 points to form a line. But all 4 of these points are non-collinear. Okay, name 3 points that are not coplanar or non-coplanar, not on the same plane. Well, 2 of the points are going to have to be on the same plane, so we'll pick A, M, and R. Okay, now this is the plane right here, okay? So obviously A and M are on this plane, but R is not. Now any 3 points can form a plane, so these guys could be on the same plane, but as far as if we're looking at this plane right here, we're saying that R is not on that plane, so it's non-coplanar. All right, number 1D, name where plane V and RN, or line RN, intersect. All right, so here's plane V. This is the one I just pointed out. And this line RN, it actually pierces through it like somebody shot an arrow through the plane. So a plane and a line will always intersect at one point, and they intersect at point N. All right, number 1E, state 3 different ways to name line AN. All right, well, here's line AN. We've already stated a couple of them, but we could say line NA. That's another way. It's just reversing the letters. We could say line AX, line XA, and line NX, and of course line XN. All right, moving on. Number 1F, state 4 different ways to name the plane V. All right, names 4 different ways to name plane V. Well, plane V obviously is one way, but we'll name it 4 other ways. All we need to name a plane is 3 letters. So we could say plane ANM. And when I say we need 3 letters, we need 3 letters that are non-collinear or not on the same line. So we couldn't say plane ANX because those are collinear and there's millions of planes that could be represented by those 3 letters. So they have to be non-collinear. So A, N, and M works. We could say plane XMC. Or sometimes we'll even draw this little parallelogram to show that we're talking about a plane. So we could plane CNA. And if we wanted to say plane, I don't know, AXC. So any 3 points that are on the plane that are not collinear. So we could not say plane MNC to represent this plane, or plane ANX would not work. All right, moving on. Name 2 opposite rays. All right, well, there are only 2 sets of opposite rays here. We could say ray NM and ray NC. Those are opposite rays. Remember, they have the same endpoint and head off in opposite directions. So ray AM is right here, heads off this direction, and ray NC is right here. They head in different directions, same endpoint. We could also say ray NX and ray NA would be another set of opposite rays. Okay, now name a different pair of opposite rays. All right, well, I just did ray NX and ray NA. And remember, a ray is always represented with an endpoint and what direction it heads off to, and we have to show that right there. All right, does point M lie on line RN? All right, well, here's point M, and there's line RN. So no, it does not. Does point X lie on AN? Okay, well, here's line AN, and there's X, so yes. Does point R lie on plane ACN? All right, so this is a tricky one for some of you guys. You have to remember that point R is piercing through the plane, so that is a no. I is line segment. Remember, when we have 2 letters with just that little line segment, no arrows, it means line segment AN. So is line segment AN in the same plane as line segment RN? Well, let me see. Here's AN, and there's RN, and you have to say no, it is not. It's not, because this line RN is piercing through the plane, so that's a no. Is line segment CX in the same plane as line segment RN? Okay, well, here's line segment CX. We have to draw it. And line segment RN, again, it's no, because RN is piercing through the plane and CX is actually lying on the plane. So that's a no. Is line segment AN in the same plane as line segment MN? Okay, well, here's AM and there's NM, so that would be a yes. Does AN plus NX equal AX? Does AN plus NX equal AX? And that is a yes. That's what we call segment addition postulate. Does CR plus RM equal CM? Okay, well, I've made a pretty good mess of this, but CR is right there, and RM is right there, and that would be a no because C, R, and M are non-collinear or not on the same line. Does line CM plus line MN equal line CM? Let's see here. Line CM, I've made a pretty big mess of this, is right here. And line MN is right here. And so yes, it does. All three of those are just different names for the same line. So can you add two lines together and get a third line? I guess the answer would be no. These three are all the same line, so you can't add these two together because they're the same line. So that would have to be a no. Well, if there are any questions on this first section, don't hesitate to email me. When I get emails about a lesson or some solutions that I did, I will get right back to you on email, but I will hopefully in my next video go over that problem for you and everybody else. I hope that helps. All right, let's go on to number 2. Number 2, point K lies on PQ and point L lies on TQ. John claims that all 5 of these points can be collinear, and Mary says they do not have to be all collinear. Draw a diagram to support John and one to support Mary. They're both right. So we have point PQ and point TQ, and we have K and L. So 5 different points, and if we just draw a line to support John, it's pretty simple. Whoop, should have used a straight edge. But I could put point P and point Q and point T. So there's line PQ and there's line QT, definitely, or TQ, excuse me, all the same line. And then we just put point K on there, and we put point L on there, and we can see, yes, John is correct. All of these are collinear points, all 5 of them. Now, Mary says that they don't have to be all collinear, and Mary is right also. What we're going to do is draw 2 intersecting lines. And hopefully you already know that the point of intersection is point Q, because that's the point that both of them share, PQ and TQ. So we'll put P out here. Make sure we put those arrows to show that it's a line, and we'll put point T over here. So we have line TQ, and we have line PQ. And let's see, K lies on line PQ, so we'll put K over here. And we know that I believe it's L lies on TQ, so you can see that John could be right and Mary could be right as well. All right, moving on to these questions. I'm going to do 4A and 5A and leave 4B and 5B for you to do. So these are segment addition postulate. Whenever you can, either draw a diagram or put your information on the diagram. When I go to give partial credit on tests, I always look for a good diagram. So this one says PQ is 3x plus 8. Well, here's PQ, 3x plus 8, and QR is 7x plus 3, and here's QR, so I'll put 7x minus 3, excuse me. Make sure I got them right. And PR, which is the whole length, is 45. So what we can do is put 45 here. We can just draw arrows to show that we're going the whole length. So hopefully you can see that PQ plus QR equals PR. Or in other words, 3x plus 8 plus, and you can put them in parentheses, 7x minus 3 equals 45. All right, now the parentheses aren't really necessary because we don't have to distribute anything, so we're just going to combine like terms. 3x plus 7x is 10x, and 8 plus negative 3 is positive 5, and that equals 45. Okay, I'm going to subtract 5 from both sides, leaving 10x equals 40. Divide both sides by 10, I get x equals 4. So that's the first thing. But remember, in geometry, rarely are we done after we find the variable. They want to know what PQ is. Well, PQ equals 3x plus 8, which means PQ equals 3 times 4 plus 8, which means PQ equals 3 times 4 is 12 plus 8 is 20. All right, QR. Well, QR is and when we don't put anything above it, this means the length of PQ. Here we're saying the length of QR equals 7x minus 3, which means the length of QR equals 7 times 4 minus 3, which means QR equals 7 times 4 is 28 minus 3, which is 25. All right, moving on to 5. It says A is the midpoint of BC. Draw a diagram that represents this information for each problem. All right, so we're just going to draw a line segment here, and we're going to call this B and C, and it says A is the midpoint. So we're going to draw A here, and that tells us that BA is equal to AC. BA equals AC because A is the midpoint, which means it cuts BC in half. So we have 2 equal halves. It says what is the length of AB is 7x minus 9, and AC is 5x minus 1. Okay, now since we know that BA and AC are congruent, we can say they're equal. So we can say their lengths are equal. So 7x minus 9 equals 5x minus 1. We'll subtract 5x from both sides. Subtract 5x from that side, it's gone. Subtract 5x from 7x, and we get 2x. We'll add 9 to both sides. We add 9 to this side, it goes away. We add 9 to negative 1, and we get 8. Divide both sides by 2, and we get x equals 4. Okay, but they don't want x. Don't put 4 as your answer because you're going to get it wrong. They want the length of BC. All right, well, we know that BC equals BA plus AC, but another way of saying that is BC equals 2 times the length of BA. And we know that BC equals 2 times 7x minus 9, which means when we plug in 4 for x, we get 7 times 4 minus 9, which means BC equals 2 times 7 times 4 is 28, minus 9 is 19, so BC equals 38. Notice I didn't distribute because I could simplify this all the way down to one number. Don't distribute unless you have a variable in there. And I see that I just almost ran out of room there, so hopefully you guys can see that okay. Leave that up there for a second. All right, so what I'd like to see is you guys do all of 3 and 4B and 5B. Again, if you have questions, email me and I'll go ahead and finish those for you. Moving on to number 6. Okay. On a number line, point R is at negative 12, and the midpoint of RS is at 5. Draw a sketch and find the coordinates of point S. All right. So this one is a tricky one for you guys, but if you'll draw the picture, it really isn't all that tough. So we know that R is at negative 12 here, okay? And somewhere out here is S. But we know the midpoint of S is at 5. So we'll just put that here because we know that the midpoint, which is about halfway between those 2 points, is 5. All right, so this is R, and this is S over here. So it says, on a number line, point R is at negative 12, and the midpoint of RS is at 5. Draw a sketch and find the coordinates of S. So hopefully you see this is line segment RS. We know R is at negative 12, and we know the midpoint is at 5. Well, what's the distance between 5 and negative 12? Well, you could simply go 5 minus negative 12, and we add the opposite, and we get 17. So the distance between R, and let's just call this point M, so the distance between RM, or the length of RM, is 17. Well, M is the midpoint of RS, so we know if RM is 17, we know that MS has to be 17 as well. Well, what is 5 plus 17? 22. Very good. So S is at 22. All right. I'm going to do number 7 for you as well because this gives us a lot of good definition about angles, the second part of our unit. So name angle 4 in 2 different ways. So here's angle 4. So this is the angle we're talking about. So when we're talking about naming angles, we always want to put that little angle symbol. And then it's just 3 letters with the vertex always in the middle. So we can name this angle MPL. Or we can name it angle LPM. All right, name a pair of linear rays. A pair of linear rays, okay? That's not a very good, we usually don't say that, but I think what we're looking for here is opposite rays, okay, or a linear pair, okay? A linear pair is 2 angles that add up to 180 degrees. So probably an easy one, a linear pair, would be right here, okay? So angle OPQ and angle QPL are a linear pair. Now I may be reading that wrong, but I think what we want here is a linear pair. Name a linear pair. I don't think they want that rays. Name a linear pair, I think that's supposed to be. Okay, 7C, name a pair of adjacent angles. Remember, adjacent angles mean they share a side or a ray. So let's go with angle NPM and angle MPL. Notice the PM and PM here. Okay. An acute angle, well, remember an acute angle is less than 90 degrees, so I think we could say angle LPQ. And an obtuse angle, well, that's greater than 90 degrees, so I think angle NPL would work. These are not the only acute angles or obtuse angle, just one. Now let's see, a right angle. Well, they really didn't give us anything here. Let me see, am I missing something? Because we don't have any information about the angles themselves, we really can't say which one is a right angle. But I would say it looks like, if we want to go off of looks, which is not ever a good idea, we could say angle MPL looks like a right angle. And a straight angle. Remember, that's just a line. So here's a line, so we'll call this OPL. It's a line with 3 letters. Angle OPL is a straight angle. It means 180 degrees. Okay? All right. 2 angles that are congruent, and why? Well, we know that angle OPM and angle QPL are congruent because they're vertical angles. I've told you many times how important vertical angles are. Two angles that are supplementary angles. All right, let's go back to the beginning. We mentioned these two angles. Here's a straight angle, so we can say angle OPQ and angle QPL. And because PQ just makes the straight angle OPL two angles. Point P is the vertex of angle LPQ. The sides of LPQ are ray PL and ray PQ. Remember, an angle is made up of two rays that have a common endpoint. All right, so I'm going to leave number 7L for you guys to do. I'm going to leave number 8 and 9 for you guys to do. And again, remember, I'll be putting up a video for Math 1 every morning about 10 o'clock. They will be notes on the current lesson and some solutions to the previous day's worksheet. All right, I hope you guys are all taking care of yourselves, staying inside, and keeping up that social distancing. Take care.